Welcome back to our channel, that is Ajay Kumar Yadav, and today we are going to see the different types of graphs with respect to speed time. So today's concept we are going to talk about different types of graphs. Same graphs we are going to see, so many graphs are there, different types of graphs. In that different types of graphs, we are going to talk frankly about the speed and time. So you know what is the speed time graph. Let us see. It's very simple concept actually. If you if you listen to the class, you will come to know what is exactly happening with the graph and the class. So this is my graph, and here this is my x-axis, this is my y-axis, this is my y component is speed, and the time component will be x. So now the graph is behaving in this style. The graph is behaving in this style. So this is the real graph which we are going to discuss today. Okay, so very first point we are going to talk about is when the body is moving upward. For point number 1, when the body is moving upward. If the body is moving upward, when the body is moving upward, what will happen? When the body is moving upward, its speed decreases uniformly. When the body is moving upward, as if you can consider it is in towards the gravity or against the gravity, speed decreases uniformly. Speed decreases uniformly. The speed decreases uniformly as the body is moving upward. At the same time, and it becomes the zero at the highest point. Becomes zero at the highest point. Becomes zero at the highest point. You know why? What is the highest point? It reaches to zero. That is the highest point of the body which is moving upward. Okay. So the same thing which we are going to discuss, the fourth point. What is the fourth point? It is speaking about as the body is coming down. As the body is coming down, as the body is coming down, what will happen? As the body is coming down, in the sense the speed increases uniformly. One next point, speed increases uniformly. Speed increases uniformly. Okay, and the last point but not the least, the body returned with the same speed in which it was thrown up. The body return with the same speed in which it was thrown up. It was thrown up. It was thrown up. So this is how we have to understand from the speed time graph. And the next graph which we are going to discuss in the today's section, that is one more type of an speed and time graph, and that graph have to be behaving like this. So you can understand what is this graph is all about. This is my x-axis, this is the second type of graph, x and y axis, this is my speed component, and this is my time component. Okay, so this is my speed and time component, and the behavior of the graph will be like this. This is the behavior of the graph. Okay, so let us see what is actually happening with the graph. So in the very first point, we can say that you can consider mass of the body as ball. The ball is dropped on the ground. First point, ball is dropped on the ground. Ball is dropped on the ground. What will happen? Speed of the body increases. Drop down the ground from the particular height. From the particular height. From the particular height. Ball is dropped on the ground from the particular height. So what will happen to the speed? Ball is dropped on the particular height. So speed increases, obviously we know very well, speed increases. If the speed increases, definitely what will happen? The body speed will be increases in the sense, obviously its velocity also increases. Then the next point, as the ball is bouncing back, as the ball is bouncing back, as the ball is bouncing back, what will happen there? If the ball is bouncing back, its speed decreases uniformly. Its speed decreases, its speed decreases uniformly. Its speed decreases uniformly, and at the same time becomes zero at the highest point. 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 So let us recapitalize the point one by one. This is the speed time graph. When the body is moving upward, its speed decreases uniformly, becomes zero at the highest point. When the body is coming down, speed increases uniformly, returned with the same speed in which it was thrown up. See the second speed time graph. The second speed time graph, body in the sense of an body, they have taken as a mass of a ball or mass of the body. The ball is dropped on the ground from the particular height. Its speed is increases as the ball is bouncing back. Speed is increases and reaches to the maximum point. Next, as the ball is bouncing back, its speed is decreases uniformly, becomes zero at the highest point. So this is how the graph have to be learned for the speed and time. Between the speed and time. Between the speed and time. That's all about the today's class. Don't forget to like, subscribe the channel. If you have any queries to clarify, you can comment on the comment section. Thank you very much for the present class. Thanks a lot.